In the first hours of that fateful day, the Red Army was caught completely unprepared. Entire airfields were destroyed before their planes could even take off. Armored divisions were surrounded and annihilated. In just 3 weeks, German forces advanced 600 kilometers into the interior of the Soviet Union. It seemed nothing could stop them. But this is not a story about generals or great battles. This is the story of men who rarely appear in history books: the mechanics, the welders, the improvised blacksmiths, men covered in grease and soot, working under enemy fire, with inadequate tools and non-existent parts, men who, with desperate creativity and brutal ingenuity, kept machines running when all logic said it was impossible. This is the story of how necessity became the mother of 1,000 inventions, how pieces of scrap metal transformed into extra armor, how agricultural tractors became combat vehicles, how ordinary men, fighting against the impossible, found solutions that changed the course of the war. Welcome to the untold story of Soviet field workshops during Operation Barbarossa. In the first weeks of the invasion, the situation of Soviet armored forces was catastrophic, not just because of German tactical superiority or the element of surprise. The problem was far more fundamental. The Soviet war machine was literally breaking down. The T-34 tanks, which would later prove to be the best armored vehicles of the war, were still new in June 1941. They had been produced hastily, in massive quantities, and with quality control standards that left much to be desired. Many had factory defects. Transmissions failed after just a few hours of operation. Engines overheated, tracks came loose. And then there were the older tanks, T-26, T-28, BT-7, machines already worn down by years of use and inadequate maintenance. When the war began, it's estimated that only 50% of Soviet tanks were in combat condition, and that number was falling rapidly. Lieutenant Mikhail Sokolov, chief mechanic of an armored brigade stationed near Minsk, would later recall, "On the third day of the war, we had started with 42 tanks. Only 18 were still running, not from enemy action. They simply stopped working, and we had no parts. We had no proper tools. We didn't even have a safe place to work." Central repair workshops had been evacuated or destroyed in the first days of the war. Supply lines were cut. Spare parts depots had been captured by the enemy or abandoned during the chaotic retreat. Mechanics faced an impossible dilemma. Hundreds of tanks sat idle, not from combat damage, but from simple mechanical failures. A blown gasket, a broken bearing, a defective valve, components that, in normal times, would be replaced in minutes. But there were no replacement parts, and the enemy would not wait. It was in this moment of absolute desperation that something remarkable began to emerge. A culture of improvisation, of ingenious workarounds, of solutions that no field manual would ever approve, but that worked. In a forest near Smolensk, a sergeant named Pavel Denisov faced a seemingly insurmountable problem. 3 T-34 tanks in his unit had stopped with burned-out transmissions. The main gears were destroyed, melted by the excessive heat of days of continuous operation. There were no spare gears. There was no way to order parts. There wasn't even reliable communication with higher command. Denisov looked at those 3 30-ton tanks and refused to accept them as total losses. Using basic tools and an improvised blowtorch, he and his team completely disassembled the 3 transmissions. What they found was devastating. 9 main gears, all damaged. But then Denisov had an idea. Not all the gears were equally damaged. Some had broken teeth on one side, but the other side was intact. Others had cracks, but still maintained sufficient structure. If he could combine the good parts from 3 bad transmissions, perhaps he could create one functional transmission. For 2 days and 2 nights, under the cover of trees and with sentries watching the sky for German aircraft, Denisov's team worked. They disassembled, measured, filed, adjusted. combined parts that were never designed to work together. They used agricultural tractor grease when military grease ran out. They fabricated washers from metal plates from an abandoned truck. They improvised gaskets using leather from old boots soaked in oil. And it worked. The tank returned to operation. It wasn't perfect. The transmission made strange noises. It probably wouldn't last as long as a new transmission. But it worked. And in June 1941, working was all that mattered. Denisov's technique spread from unit to unit, from mechanic to mechanic, passed along verbally, demonstrated in practice. There was no time for manuals or formal training. It was learned by doing or watch tanks rot on battlefields. But the improvised genius of Soviet mechanics went far beyond just repairing broken parts. They began to modify the tanks themselves, adapting them to the brutal realities of the war they were fighting. One of the most lethal problems of the early T-34 was the driver's hatch. It was small, difficult to open quickly, and positioned so that when the tank was hit and began burning, the driver often became trapped. Many crew members didn't perish from the initial shell impact, but from being trapped in burning vehicles. In field workshops all along the front, mechanics began modifying these hatches. Using improvised cutting equipment, they widened the openings, modified the hinges to open more quickly. Some even installed emergency ejection systems made from truck suspension springs. These unauthorized modifications saved countless lives. And although they completely violated factory specifications, commanders quickly learned to turn a blind eye. A modified tank with a living crew was infinitely more valuable than a tank within specifications with a deceased crew. Another critical problem was armor. Early T-34 models had adequate armor for the beginning of the war, but the Germans quickly began employing more powerful anti-tank guns. Shells that previously ricocheted now penetrated. The official response would have been to increase armor thickness at the factory, but that would take months. Field mechanics didn't have months. They had days, if they were lucky. And so began the practice of improvised armor. Any piece of metal that could be welded to a tank hull became extra armor. Steel plates from destroyed railway cars, vault doors from abandoned banks. Even railroad tracks were cut into sections and welded to the flanks of tanks. A captain named Yuri Volkov, commander of a tank company near Kiev, watched his crews welding irregular pieces of metal onto their vehicles, and was initially horrified. It looked desperate. It looked amateur. Until the day a German 75mm shell hit one of his T-34s directly on a spot covered by a piece of welded railroad track. The shell penetrated the track but lost enough energy that the tank's main armor stopped it. The crew survived. The tank continued fighting. Volkov never questioned improvised armor again. But there was a problem. Welding additional metal significantly increased the weight of the tanks, and additional weight meant more pressure on already overworked engines, on already defective transmissions, on already worn tracks. The solution came from a mechanic whose name was lost to history, but whose idea spread like wildfire. Spaced armor. Instead of welding metal plates directly onto the tank hull, they began installing metal structures that kept the plates a few centimeters away from the main armor. When an armor-piercing shell hit this spaced armor, it detonated or deformed before reaching the tank's main hull. It was a principle that would take years to be officially adopted and studied. But in the field workshops of 1941, it was born of pure necessity. And it wasn't just tanks that received the improvisational treatment of Soviet mechanics. The shortage of armored vehicles was so severe that mechanics began converting anything with an engine and wheels into combat vehicles. Tractors, trucks, even civilian automobiles. If it moved, it could be weaponized. In a depot near Tula, a group of mechanics led by a man named Konstantin Baranov faced an unusual order. Their unit had received a shipment of 20 agricultural tractors, sturdy machines designed for plowing fields, not fighting wars. They were also assigned 50 machine guns with no vehicles to mount them on. The solution seemed obvious to Baranov. Turn the tractors into combat vehicles. Using metal plates salvaged from bombed-out buildings, they constructed improvised armor around the tractors. The armor wasn't thick, wouldn't stop a direct hit from anything substantial, but it would protect against small arms fire and shrapnel. They mounted the machine guns on improvised turrets made from oil drums and steel pipes. They reinforced the wheels with chains and metal plates to prevent punctures from debris. The result looked absurd. Slow, ungainly, patched together from a dozen different materials. But when German infantry encountered these improvised combat vehicles during a counterattack near Tula, they were caught completely off guard. The tractors weren't fast, but they were reliable. They kept moving through mud that would bog down proper tanks. And the machine gun fire was just as lethal whether it came from a purpose-built armored car or from a converted farm tractor. Baranov's improvised fighting vehicles bought precious time for Soviet forces to reorganize, and the concept spread. Throughout the Soviet rear areas, tractors, trucks, and even cars were converted into makeshift armored vehicles. Some historians estimate that in the autumn of 1941, as much as 15% of Soviet mechanized units included some form of improvised vehicle. They weren't recorded in official records. They wouldn't appear in victory parades. But they fought, and many of them made a difference. The ingenuity of Soviet mechanics extended to recovering disabled vehicles from battlefields. In conventional military doctrine, a tank knocked out in enemy-controlled territory was considered lost. But the Soviets couldn't afford conventional doctrine. Recovery teams, often composed of mechanics with minimal combat training, would venture onto battlefields at night to retrieve damaged tanks. Under cover of darkness, with German positions sometimes just hundreds of meters away, they would attach cables to disabled tanks and drag them back to Soviet lines. These missions were extraordinarily dangerous. Recovery vehicles were slow, vulnerable targets. Many mechanics lost their lives in these operations. But the recovered tanks were invaluable. A damaged tank that could be repaired was worth its weight in gold. Even tanks that couldn't be repaired became sources of spare parts. AT-34 with a destroyed turret could provide a working transmission for another tank. A tank with a broken engine could donate its gun, its optics, its radio. Senior Sergeant Andrei Petrov led a recovery team operating near Vyazma in October 1941. In a single month, his team recovered 37 tanks from battlefields. 13 were repaired and returned to service. The remaining 24 were cannibalized for parts that kept dozens of other tanks operational. Petrov's method was systematic and ruthless in its efficiency. His team would scout a battlefield during daylight, identifying targets and planning routes. At night, they would move in with recovery vehicles, often under enemy fire. They developed techniques for quickly assessing whether a tank was worth recovering or should be stripped for parts on the spot. They carried specialized tools for rapid disassembly, pneumatic wrenches powered by portable compressors, cutting torches, heavy-duty jacks, everything needed to remove critical components quickly. On one occasion, Petrov's team was recovering a disabled T-34 when German forces launched a night attack. Rather than abandon the tank, Petrov and 3 mechanics climbed inside and used its functioning machine gun to help repel the attack. The tank's main gun was inoperable, its engine destroyed, but its defensive armament still worked. After driving off the Germans, they completed the recovery operation, towing the tank back to Soviet lines by dawn. This kind of determined resourcefulness became characteristic of Soviet mechanics throughout the war. They refused to accept limitations. They refused to accept losses as final. Every mechanical problem was a puzzle to be solved, not an insurmountable obstacle. As autumn turned to winter in 1941, Soviet mechanics faced a new and terrible challenge. The legendary Russian winter. German forces, expecting a quick victory, were unprepared for winter warfare. Their vehicles froze. Their lubricants became solid. Their soldiers suffered from frostbite and hypothermia. But Soviet vehicles, despite being designed in Russia, weren't much better prepared. The T-34 had a powerful diesel engine, but diesel fuel could gel in extreme cold. Batteries lost charge rapidly in sub-zero temperatures. Metal components became brittle and prone to cracking. Once again, field mechanics developed solutions. They began adding alcohol to diesel fuel to prevent gelling, not the refined antifreeze that would later become standard, but whatever alcohol they could obtain, sometimes military-issue vodka, sometimes pure alcohol from medical supplies, sometimes industrial alcohol. The mixture ratios were determined through trial and error. Too much alcohol and the fuel burned too hot, damaging engines. Too little, and the fuel would still gel in extreme cold. Mechanics became expert at judging the right mixture by temperature and conditions. For batteries, they developed a system of removing them from vehicles at night and keeping them warm near fires or inside heated shelters. Every morning before dawn, teams of mechanics would go from vehicle to vehicle, reinstalling the warmed batteries. It was labor-intensive and time-consuming, but it worked. Soviet tanks could operate in temperatures that completely immobilized German vehicles. They also developed improvised heating systems for engines. Using sections of pipe and redirected exhaust, they created ways to keep engine blocks warm, even when the vehicles weren't running. Some mechanics installed wood-burning stoves under tank hulls, carefully vented to prevent carbon monoxide poisoning of crews. These innovations gave Soviet forces a crucial advantage during the winter counteroffensive that saved Moscow. As German forces froze in place, unable to maneuver their vehicles, Soviet mechanized units, kept running by their resourceful mechanics, launched counterattacks that pushed the invaders back from the gates of the capital. But perhaps the most impressive achievement of Soviet mechanics during Operation Barbarossa wasn't any single innovation or technique. It was the creation of an entire culture of improvisation and adaptation. In official Soviet military academies before the war, maintenance was taught as a rigid by-the-book process. There were proper procedures, proper parts, proper methods. Deviation from standards was discouraged. The reality of war destroyed all of that in weeks. Mechanics who survived the first months of Barbarossa learned to think differently. They learned to look at any material as a potential resource. They learned to question assumptions. They learned that a solution that worked was infinitely better than a proper solution that required resources they didn't have. This culture was transmitted informally. Experienced mechanics would take younger ones under their wing, teaching them tricks and techniques. Some units developed their own specialized knowledge, passed down as veterans-trained replacements. A mechanic named Viktor Sorokin, who served from the first day of Barbarossa until the fall of Berlin, kept a notebook throughout the war. It wasn't an official document. It was his personal collection of improvised solutions, sketches of modifications, notes on materials that could substitute for standard parts. By the end of the war, his notebook contained over 200 pages of hand-drawn diagrams and detailed instructions. After the war, he shared it with other veterans, and copies circulated informally among Soviet military mechanics for decades. That notebook, and countless others like it, represented a parallel technical manual. The official Soviet military technical documentation told mechanics how tanks were supposed to be maintained. These informal notebooks told them how tanks actually were maintained in the field, under fire, with insufficient resources. The impact of these field innovations extended beyond just keeping vehicles running. They influenced Soviet tank design for the rest of the war. Engineers and designers who visited the front and saw the modifications mechanics were making began incorporating those ideas into official designs. The improved driver's hatch that mechanics had been improvising, It became standard on later T-34 models. The concept of spaced armor? It was officially integrated into new tank designs. The T-34 itself evolved throughout the war, and many of those evolutions were directly inspired by field modifications that mechanics had developed out of necessity. Soviet doctrine also changed. The rigid pre-war approach to maintenance and repair gave way to a more flexible system. Field repair workshops were given more autonomy. Mechanics were encouraged to develop local solutions rather than waiting for parts from central depots. By mid-1942, the Red Army had formalized what had begun as desperate improvisation. Mobile repair workshops, equipped with basic machine tools and staffed by experienced mechanics, could perform major repairs close to the front lines. These workshops could fabricate parts, modify vehicles, and return tanks to service in days rather than weeks. They represented an institutionalization of the improvisational spirit that had emerged during the darkest days of Barbarossa. But let's return to those early days, because not all innovations were successful. The desperate circumstances also led to solutions that failed, sometimes spectacularly. Some mechanics, trying to increase firepower, attempted to mount larger guns on tank chassis, not designed for them. The recoil forces would crack welds, damage mounting points, sometimes even flip lighter tanks over when fired. Others, trying to increase speed, would remove armor plating to reduce weight. This sometimes worked from a performance standpoint, but it turned tanks into death traps. A vehicle that's faster but can't protect its crew is worse than useless. There were attempts to create flamethrower tanks by modifying standard vehicles. Without proper understanding of pressure systems and fuel management, several of these improvised flame tanks resulted in tragic accidents, with vehicles consumed by their own weaponry. The mechanics learned from these failures, too. They learned that some shortcuts weren't worth taking, that some innovations were too dangerous, that engineering specifications existed for reasons. The story of Soviet mechanics during Operation Barbarossa is not just one of triumph. It's also a story of trial and error, of learning through failure, of men who died because an improvised solution didn't work as hoped. But overall, the balance sheet of these field innovations is remarkable. Conservative estimates suggest that improvised repairs and modifications kept at least 20 to 30% more tanks operational than would have been possible using only standard procedures and official spare parts. That's thousands of tanks, thousands of vehicles that should have been written off as losses, but instead returned to combat, often multiple times. The psychological impact was significant, too. German forces were continuously surprised by the resilience of Soviet armored units. Tanks they had destroyed or disabled would somehow reappear days later. Units they thought they had eliminated would reform and counterattack. Some German after-action reports from late 1941 express frustration and even a kind of grudging respect for Soviet mechanical resourcefulness. One German tank commander wrote, "We can destroy their vehicles, but we cannot seem to destroy their ability to put them back together from nothing." The mechanics themselves rarely received recognition during the war. They weren't heroes in the traditional sense. They didn't lead charges or win dramatic victories. They worked in the background, in the mud, in the cold, under fire. Many died, not in glorious combat, but in workshop accidents from exhaustion, from exposure to the elements, from random artillery shells that found their workshops. The Soviet system wasn't particularly good at acknowledging these quieter forms of heroism. A tank commander who destroyed 10 enemy tanks would receive medals and recognition. A mechanic who kept 20 tanks running, enabling 200 crew members to fight, might receive nothing at all. But among tankers, mechanics were revered. Experienced tank crews knew that their survival depended as much on the skill of their unit's mechanics as on their own combat abilities. A good mechanic was worth his weight in gold. There's a tradition that developed in Soviet tank units during the war. When a tank crew celebrated a successful combat mission, they would include their mechanics in the celebration. They would save rations for them, share captured supplies with them, protect them from overzealous officers who might try to reassign them. Because they knew a tank was only as good as the mechanic who maintained it. As we reach the conclusion of this story, it's important to reflect on what these mechanics represented. They were mostly young men, many barely trained, thrown into impossible situations with inadequate resources. In any reasonable analysis, they should have failed. The problems they faced were too large, the resources too scarce, the time too limited. But they didn't fail. They succeeded through creativity, determination, and a willingness to try solutions that no textbook would have recommended. They embodied a peculiarly Soviet form of resourcefulness. In Russian, there's a word that doesn't translate perfectly into English: smekhalka. It means something like clever resourcefulness, the ability to make do with what you have, to find solutions through ingenuity rather than resources. Soviet mechanics during Operation Barbarossa were masters of smekhalka. They turned scrap metal into armor, failed parts into working transmissions, agricultural equipment into weapons of war. And in doing so, they helped stop the largest invasion in history. When German forces stood at the gates of Moscow in December 1941, exhausted and overextended, one of the factors that saved the Soviet capital was simple. The Red Army still had tanks that worked. Not because factories had produced enough new ones, though they had performed heroically, but because mechanics had kept old ones running through sheer force of will and creativity. Every improvised repair, every modified hatch, every piece of salvaged armor, every recovered tank, every technique shared between mechanics contributed to survival, and survival in the winter of 1941 meant the possibility of eventual victory. The story of Soviet mechanics during Operation Barbarossa reminds us that wars are not just won by generals and armies. They're won by countless individuals doing extraordinary things in ordinary circumstances, by people who refuse to accept that something is impossible simply because it's never been done before. These men, whose names are mostly lost to history, whose innovations were never officially documented, whose contributions were rarely acknowledged, played a crucial role in one of the most important military campaigns in human history. They were not heroes in the conventional sense. They were simply men doing a job that needed to be done under impossible circumstances with insufficient resources. But perhaps that is the truest form of heroism. Not glory on the battlefield, but quiet determination in the workshop. Not dramatic victories, but patient solutions to mundane problems. Not seeking recognition, but simply doing what needs to be done. The next time you hear about the Soviet victory at Moscow, or the eventual triumph at Stalingrad, or the long march to Berlin, remember the mechanics. Remember the men covered in grease and oil, working through the night to keep one more tank running for one more day. Remember that behind every successful military campaign, there are invisible heroes. And in Operation Barbarossa, many of those heroes held wrenches, not rifles. This has been the story of field innovations of Soviet mechanics during Operation Barbarossa, a story of creativity born from desperation, of ingenuity forged in the fires of total war, of ordinary men who accomplished extraordinary things. Their legacy lived on long after the war. The culture of improvisation they created became part of Soviet and later Russian military tradition. The innovations they developed influenced tank design and maintenance doctrine for decades. But more than that, they proved something fundamental about human resilience and adaptability. When faced with impossible odds and insufficient resources, human ingenuity can find a way forward. The mechanics of Operation Barbarossa didn't just fix tanks, they helped fix the course of history. And that achievement, accomplished with basic tools and improvised solutions, stands as a testament to what can be accomplished when necessity, creativity, and determination combine in the crucible of war. June 22, 1941, 3:15 in the morning. Along a border stretching over 3,000 kilometers, the silence of dawn was shattered by the roar of thousands of engines and the thunder of artillery. Operation Barbarossa had begun. 3 million German soldiers, supported by 3,650 tanks and nearly 5,000 aircraft, crossed the Soviet border. It was the largest invasion in military history.